what is polynomials? Well, you know the name like polynomials, but what is it? The definition is very important. A polynomial is an algebraic expression often written as px. Okay, if that's a polynomial, we don't write fx, we write px. That contains, okay, three things: non-negative, whole number, power. Okay, this expression must contain non-negative, whole number, and power. Okay, three things. They must happen at the same time. So, for example, I give you some expressions here. 1 over x plus 2x. Okay, this is not a polynomial. This is not a polynomial. Why is not a polynomial? That's x to the power of -1. It failed the non-negative. Okay, it is negative. So it failed that one. So that's not a non-negative power. So that's not a polynomial. Okay, for that, x squared minus 1. We have x squared minus 1. That's to the power of half. Half is not whole number. Half is not whole number. So that failed a polynomial as well. Okay, we can't have that one. Okay, that one, you say, that looks whole number, non-negative. That's good. But, okay, your power cannot include variable. The power cannot include variable. Okay, so those two powers are not number. You must have non-negative number power. It's not variable power. So this is called polynomial. Okay, this is called polynomial. Like say x to the power of 4. That is polynomial. Non-negative integer power, all good. But 4 to the power of x is not polynomial. That's called exponential. When you have x or variables in your power, that is called an exponential, not a polynomial. Okay, polynomial, you must have a variable base, but not the power. Power must be a number, non-negative integer number. Okay? So this is polynomial. So in general, an expression of px written in this form. So we write that in a decreasing order of the power. So x power of n minus 1, n minus 2, well, until 2, 1, and constant. Okay, make a note here. Constant is polynomial. Okay, constant is polynomial. Why constant is polynomial? For example, 2. 2, I can say that's 2x to the power of 0. Okay, I can say that's 2 times x to the power of 0. That's a 0 power. Well, I just say non-negative, but I didn't say 0 can't be. 0 can be the polynomial. Okay, 0 power can be the polynomial. So constant is polynomial as well. Okay, constant is polynomial as well. So what we have here is an expression. So what is px? Well, give your example. What is px? So px, I can say that 3x to the power of 2 plus, well, let's go 3. 3x to the power of 3, 4x to the power of 2 plus x plus 1. That is called a polynomial. So it's just a lot of terms adding together, and each term got non-negative integer powers. Okay, and we write that in a decreasing order. We write that in a decreasing order. That is called polynomials. So some names. What is coefficient? Coefficient is the number you times in front of the x. For example, in my case, in my expression, 3, 4, 1, they are called the coefficient. 3, 4, 1, they are called the coefficient because they are like the number times in front of x. Okay, leading term. Leading term. What is a leading term? Leading term is the term of the highest index among all of those terms. Okay. This one will be my leading term. 3x to the power of 3 will be my leading term because that's the highest index. 3 is the highest index. I have index 3, index 2, index 1, index 0. So 3 is the highest one. I have that as my leading term. next one is called the degree of polynomial. Okay, degree of a polynomial. So the index n of the leading term is called the degree. So that one got a degree of 3. That one got a degree of 3. So what is your highest index? That is called the degree. Okay, your highest index is your degree. Okay, highest index is the degree of the polynomial. Okay, constant term. Well, it's the term without x. Yes? Sorry? Like highest power. Highest power, like 3 is called the index. That's the number on top. So 3 is the highest one. Constant term. Constant term is the term without x. So it's just the constant at the back, like the last number, the last constant. Okay, so that's the constant. So the terms of a polynomial are best placed in the order from largest to smallest power of x. Well, put things in order. Okay, we put things in order. Make sure every expression you write are in order. Do not just like, x to the power of 2, x to the power of 4, x to the power of 3, and then x to the power of 5. Like, do not do things like really randomly. Trying to make that from, not trying to, you must make it from the highest to lowest, because that can benefit your calculations later. It will be like so easier of your calculations. So make sure it's a good habit to put the power from the highest to the lowest. Okay, example 1. Are they polynomials? Okay, A, is that polynomial? You just need to answer me yes or no.
Yes.
Yes. Okay, number 2, is that a polynomial? B, is that a polynomial? Why not? Like not really a square root, but that's x to the power of 3 on 4. That's not integer power. Okay, that one failed. Okay, C. Yes or no? No? Yes or no? No. Okay, that term is wrong. That's 2 times x to the power of negative 1. You can't put that in the bottom and say we have a positive index. We must flip it onto the top. And then we say that's a power of negative 1. And it's negative. I need non-negative power, so that's not. D, yes or no? D, yes or no? No. Which one not? X to the power of negative 2. Okay, that's wrong. Okay, E. Yes. X to the power of 7, x to the power of 3, they're all fine. Okay, non-negative, positive integers, power. Okay, all good. Non-negative, non-negative whole number powers. Okay, satisfy everything. F. Yes. That's a 2. Okay, I can see that's a 2. So that is a whole number. Okay, that is a whole number. So that one, yes. G. Yep. Okay, power 4, all good. Okay, power 4, all good. H. No. Which one not? That is x to the power of half. It failed the whole number part. Okay, it must be a whole number power. I. Yes or no? Yes. Because constant is polynomial. Okay, constant is polynomial. Even though that's a pure constant, it's still called a polynomial. Okay, 2 is polynomial. Alright, let's name the polynomial for the next thing. Polynomials are named by its highest power of x. Okay, named by the highest power of x. Okay, but they have special names. They have special names. For example, the first one, when its highest power is 1, I call that a linear. Okay, that's a linear. Highest power is 1. Okay, y equals to x plus 2, that's a linear. Minus x, that's a linear as well. X squared. X squared, that's a quadratic. x squared is quadratic. What's the name for x to the power of 3? Cubic. Okay, cubic. How about x to the power of 3 is cubic as well? That's a cubic. How about x to the power of 4? Quartic. Quartics. Okay, how about x to the power of 5? Yeah, what's the name? Okay, we don't really give special name after quartic. We don't really give name after quartic. So what we call that is polynomial. No, I haven't finished. Polynomial of degree 5. Of degree 5. So what's the name for the next one? 7. Okay, polynomial of degree 7. Alright, so what we have is constant, linear, quadratic, cubic, quartic, and polynomial of 5, polynomial of degree 5, polynomial of degree 6, and so on. Okay, so that's the name for polynomials. Alright, next one is called the function notation. Okay, function notations are very important. Okay, function notations are very important. We use function notation like we use function notation year 11 a lot. We do not use y equals to something. Later we use fx equals something or px equals to something. Let's have a look at this notation. So function notation, a polynomial in terms of x can be called px. Okay, in terms of x can be what? X squared plus x cubed plus x power 4, that's called px. So what px use? So px equals to 2x cubed minus 2 is a cubic polynomial. So that is equivalent to say y equals to that. And that is the same. We just basically change y in terms of px. We change y in terms of px. So pk is the value. Well, you know like what's the good thing about px? So let's say we have y equals to x plus 2. We want to substitute x equals to 1. We'll say when x equals to 1, y equals to 1 plus 2, and y equals to 3. So what we need to do is that. But what's the benefit for making y in terms of px? I'll say px equals to x plus 2. Now I want to find the value where x equals to 1. So what I will do is P1. Okay, P1. We substitute x equals to 1 into the function. So that just equivalent to 1 plus 2. And that equals to 3. So this function directly tells you both x value and y value. You sub 1 into this bracket and then you get the y value. Okay, so it's 1, 3 for the points. Okay, it's 1, 3 for the points. Alright, so have a look at here. Pk is the value of polynomial at x equals to k. Okay, pk is the value at x equals to k. For example, px equals to that. Then p1 is just substitute 1 in terms of x. And then pa is just substitute a in terms of x. So you always change the x into whatever you put in that bracket. So it's like a cooking, it can be a machine, like a food machine. So what I'm doing is I put something into this machine and I produce something out. So what's the machine, how the machine working? For example, we have px equals to x squared plus 3x. Okay, so the position of x is the position you put things in. So it's same as we have some space to put things in. And then this thing will be transferred to the equation in the space of x. Okay, it's like that. Whatever I put in the bracket, that thing will directly go to the box. Okay, well, instead of what I put inside, instead of x, I'll become the new thing. For example, I want to put a plus b in this one. In this box, I want to put a plus b. And then a plus b will get into those two boxes as well. Okay, you put a plus b into the function instead of x. Okay, instead of x. So each x will become the thing in the bracket. Each x will become the thing in the bracket. So that's how you do the substitution. Okay, that's how you do the substitution. So let's have a look at this. Example 3 says, what is the value of b if px equals to that? Okay, if px equals to that. And you know that p1 equals to 4. Okay, p1 equals to 4 tells me when x equals to 1, your y value is 4. Okay, that is basically what I get from this expression. When x equals to 1, y equals to 4. So what I can write is p1. So what p1 equivalent to? Instead of x, I will write 1. Instead of x, I will write 1. Okay, instead of x, I will write 1. That is the expression for p1. So I will just simplify that. That's 1 minus 2 plus b plus 3. What I'll have is b plus 2. Also, you know that p1 equals to 4. Also, you know that p1 equals to 4. So what I will have is b plus 2 equals to 4. And b equals to 2. And b equals to 2. Okay, so that's just the notation. That's just the notation for polynomials. Okay, it's not much difference compared to y equals to something. It's just change y in terms of px, and that can give you both x value and y value. So p1 talk about x equals to 1, equals to 4. They're talking about the y value is 4. So that's what we have. All right. I'll do a little bit about this one as well, and I will ask you to do that on the board. So example 1, I want to expand that. So you know how to expand things, right? Like how to expand numbers. So that's a little bit just revision, purely revision. So for this one, I can use 2x go to time with that x. So I have 2x squared. And 2x go to times the minus half. I will have minus x. The 1 go to times x, I will have plus x. The 1 times negative half, I have that. So what I will have is 2x squared minus half. That's how we expand things. I'll just go first term times those two, second term, go to times those two. Same as number expanding. Okay, same as number expanding. Okay, example 2. Example 2. So for example 2, I'm asking, is that true for all the value of x of this expression? Anytime you are asked like something whether it's true or not, you need to think about the both sides of the equation. But you are not operating you're not operating that together at the same time. So what you need to do is you don't know whether this is a true statement or not. You can't keep the equal sign there. So I will talk about left hand side and then I will talk about the right hand side. So what I will do is left hand side equals to that. And then I also have right hand side. Well, I'm not going to do right hand side yet. I'll just expand left hand side. I want to, because the right hand side is in the expanding formula, so I'm trying to expand that one. But do not keep the equal sign in the middle and do not try to operate two sides at the same time. You only look at one side first and then you go to look at another side and compare whether they are equal or not. So we'll start from left hand side and I will say that is x squared times that is 2x to the power 4. And this one go to time with the x is plus x to the power 3. And then minus x squared. The middle one, minus x times with 2x is minus 2x cubed. Minus x squared. Go that one, plus x. Last one, 6x squared plus 3x minus 3. Should be 9 terms in total. And I will simplify it. I will count 1, 2, well, 2 terms got x to the power 3. So I will have minus x cubed for that one. And I'll count how many x squared I have. 1, 2, 3. So I have plus 4. Plus 4x squared. And then how many x I have? I have 2 more x. That's a plus a 4x. And minus 3. You have to look at this one. Is that the same compared to the right hand side? That's the expansion form. Is that exactly the same as right hand side? What has been missing, or there's no 4x on right hand side? That's correct. So there's no 4x on right hand side. So they're not the same. So this thing is not always true. Okay, this thing is not always true. So this is not equal to right hand side. So this is not true for all x. It will be true when x equals to 0. It will be true when x equals to 0. Because the 4x times 0 become a 0. So nothing on each side then. But for the other values of x, it's not going to be true. Because you will have something extra on the left hand side. So it's not going to be true. Okay, that's how you do the expansions and testing whether it's true or not for a particular expression. So again, do not try to operate things on both sides of the equation at the same time. You will separately talk about them and do not keep the middle, like the equal sign there. That equal sign it shouldn't be here until you can see left hand side is definitely equal to right hand side. Otherwise, it's like a question mark there. I'm not sure if it's true or not. Okay, so what I want you to do is doing these expansions for the next 7 questions, and I'll ask some of you come up here and then do that for me.